Okay, we are going to get started. I just want to introduce, before we get the paper out, to tell you a little bit about what you're going to be doing today. We're going to be doing something called regression. So if you had a data set, let's say you measured people's heights and their shoe sizes, and you plotted shoe size, and you plotted them on a graph, you would notice that generally, it's not always true, but generally, people that are taller have bigger feet. And you could kind of connect those, or you could generalize them with a line. You could generalize that pattern with a line. That's called a linear regression. And I say you could generalize. What I really mean is you could put the data into a calculator or into Excel, and it could figure out what the equation of that line is. Okay. Sometimes you have a data set, though, that doesn't make a line. It makes a shape like this. Here's the data. And it doesn't make a straight line. It makes something that looks a little bit more like a U shape, like one of our more recent quadratic regressions. So for this, if you saw a shape like this or data like this, you would do a quadratic regression for this. Now on the calculator, the linear regression, you'll see written linreg, linear regression, and quadratic regression, you'll see written quadreg. Okay, so let's talk about how we give the data to the calculator and then how you get the calculator to actually do the regression. So I'm going to open up my calculator and I'm going to open to the next page, or to the page that you have in front of you. And there's my calculator, y equals. Now, first thing I would do is go ahead and clear the calculator. So you hit second, plus sign, 712. And then your calculator is reset and ready to go. All right. And we're going to work on this problem here. We have a study of the speed of a car versus its fuel economy, like how many miles per gallon you get when you drive at different speeds. And I'm really just following these instructions here to get the calculator ready to do the regression for me. So I'm just following the directions for step 1, turning on diagnostics. So I'm going to hit second, catalog, which is down here, the 0. And I want to choose diagnostics on. So you can either scroll all the way down to the letter D, or if you hit this button, X inverse button, there's a little letter D here. It'll take you directly to the D's. And then you don't have to do quite so much scrolling. So I'm going to go down, oops, I missed it, diagnostics on, push enter, enter again. Okay? So that takes care of step 1. And you'll see later why we need to turn the diagnostics on. Now I'm going to go to Stat and Edit. Push Enter for Edit. You should see like a T-table that doesn't have any numbers in it yet. And what we're going to do is we're going to put these numbers into the T-table. So these are going to be all the X's, and these will be all the Y's. So these numbers, 15, 20, 25, they go in L1. And all the others go in L2. I'm going to pause the video while I do that. Please, you should also type those into your calculator to practice. Okay, I've just entered all the data into L1 and L2. Notice that I didn't stop at 45. The screen makes it look like you're supposed to stop. I entered all the data all the way to 70 in L1 and L2. Okay, now I'm going to go on over here. I'll bring my calculator right back into step 3, finding the curve of best fit. So here's my calculator. I'm going to go to Stat and then select Calc. And we're going to scroll down to select Quadreg. For this problem, we want Quadreg. Sometimes you might want to choose linear regression, but we want quadratic regression, and you push Enter. Now, on your calculator, your screen's going to look different. You're going to push Enter, I think, 4 times maybe to get the quadratic regression. You'll see it says calculate and then you push enter. I just have to push enter once. So you push enter like 4 times and you should get an output screen that looks like this. Now this lets me know that I've done something wrong in my stat. So I'm going to go back. I'm going to pause and go back and fix it. Okay. I fixed my mistake and here's my quadratic regression. Now I know that I had a mistake because my screen, my calculator screen did not perfectly match this calculator screen, but now it does. Now I have the exact same screen here as is on the paper. So make sure that you have the same numbers that are on the paper there. Everybody should work the same way if you entered the data correctly. I missed a number, and so mine didn't work. So if you find that you don't have this, go back to Stat and Edit and look for your mistake in here somewhere. Okay? Now I'm going to go Stat, and I have to Calc again to get my quadratic regression, my numbers. Okay. So we know quadratic equations are ax squared plus bx plus c. And this is telling us, hey, this is A, negative 0.008, this is B, and that's C. So I'm going to take those numbers and I'm just going to write them and put them into the equation. Now there's one thing missing on this equation, and that is that there should be a negative sign right here. You have it on your paper, but on my paper I made a mistake. So make sure you have the negative sign there because it's negative 0.008. Okay? Next thing I'm going to do, I'm going to graph this. So I'm going to go to second on my calculator. I'll go second, y equals, and press enter to turn the plots on, and then select that first choice so the plots are on. This should already be highlighted, right? So I've turned the plots on, highlighted, and now when I go to the graph, right, I'm going to go zoom, and I scroll down or select number 9. Oop, too far. Number 9, zoom stat. That's just going to make certain that all the points go on the graph. Okay, now you notice that my picture here, all the points are the same, but I don't have the curve. That's because you have to actually go into y equals and type in this equation. Okay, so I know it's quite a bit of typing, but I'm going to put exactly what I see here into this equation. I'm going to pause the video and do that. You do the same. Okay, you can see I have entered the equation here into the calculator, and now when I go back to the graph, I should see the curve just like the one in the picture here. Okay. Now the last thing to talk about, which I kind of skipped over earlier, is when you do the stat calc and you do quad reg and push enter here. It gives a number down here called r squared, right? R squared is never going to be a number that's bigger than 1, and the closer it is to 1, the better. So the fact that our r squared value is 0.96, that means that the graph, you know, that the equation that we wrote is a really good one. It really matches the data set very well. Okay, all the data is very, very close to that line. So the bigger the r squared, or the closer it is to 1, the better. All right, let's go look at the next example. Okay, we've got a pumpkin tossing contest, of course. And so the pumpkins are going to be launched from a catapult at different angles, and then they measure how far the pumpkin goes. So you can kind of see that the pumpkin will travel the farthest if you are doing it at about 40 degrees, but they tried all these different measurements. And what we're going to do is we're going to do a quadratic regression again to find an equation that will relate the angle to the distance that it travels. So I'm going to go back to the calculator, and I'll go to Stat, Edit, and to clear these right now, just so I don't have to turn, go through and turn the diagnostics back on, if you go up and then you push clear and then the down arrow, it will clear everything out. I don't think delete will work, but if you go up top and you push clear and then you push the down arrow, now everything is gone. Okay, same idea. These are x, the angles are x values, the distances are the y values. So I'm going to pause this and I'm going to enter those. You do the same. Okay, this time I check my work. Looks good. Okay, so I've entered the angles here and the distances that they travel, and now I'll go back to Stat, Calc, scroll down to Quad Reg, so we'll do a quadratic regression. Remember, you have to push enter a bunch more times. That's okay, just keep pushing enter until it spits out this result. Okay, so I'm going to take that. That is my quadratic equation. I've got an A, negative 0.261, and B is 22.591. I'm rounding to the nearest thousandth place, and C is 23.029. Okay, so I'm going to write that equation down here on the paper, and then we'll talk about how to do the next part. Okay, oopsie. So it's negative 0.261x squared plus 22.591x plus 23.029. Okay, so the next question is, based on this equation, predict the distance a pumpkin would fly if it was launched at 15 degrees. So we don't have data there for 15, right? We're trying to make a guess using our equation. This is x though, right? And this is f of x, or y, right? I'm given an x value and I want to find the y value that goes along with it. So what I have to do is I have to plug it in. I have to find f of 15. So I'm going to put this in the equation, 15 squared plus 22.591 times 15. Everywhere there's an x, I'm putting a 15. And then I can use a calculator and plug all that in, and it will tell me the distance, approximate distance that it would travel if it was launched at 15 degrees. Now, I do want to show you another way that you can do this calculation on the calculator. It's kind of cool. So I'm going to go back to my calculator. Okay. And I'm going to take this equation, this green equation, I'm going to type it into y equals, and we're going to look at it on the graph. Okay. I have to clear this one. This is from last time. So I have negative 0.261 x squared plus 22.591 x. Should have paused it. Okay, let me make sure I have that all typed in correctly. Now I'm going to know if I typed it in wrong if I look at the graph and it doesn't match up with the points. That's how I'm going to know. But I want to check right now. Okay, it looks pretty good. Now remember, to get to see the points on the graph, you have to go to zoom. Don't just click graph, go to zoom and then scroll down and you're going to select zoom stat. And that's going to make sure that all the points are on the graph. So there they are. Ooh, looks like I did a good job this time. Right? There's my equation. Now, the calculator has another feature that's pretty nice. And you might not have used this one before. If you go to second, calc, right? I had to hit second first and then the trace button. One of the things that the calculator will do is it will calculate a value. And when you click that, it takes you back to the graph and it tells you, hey, what do you want x to be? And I'll say I want x to be 15, right? Because I want to plug in 15. So I don't necessarily have to type all of this in with the 15s in those places. I can use calc value and 15. And what this is telling me is if you launch it at 15 degrees, it's going to go about 303 feet will be the distance that it travels. So I know based on my equation and plugging it into calculator, it will go 303 feet. Okay. Let me show you one more time. To do that on the calculator, I go second, calc, and I choose value, and it prompts me to type in an x. I type in 15, enter, and it spits out the y value that goes along with it. Okay? All right, one more at the bottom. The table shows a meteorologist's predicted temperatures for an October day in Sacramento, California. First, we're going to enter the data into the calculator. Now, here we've got 8 o'clock, 10 o'clock, 12 o'clock. Now, 2 o'clock in the afternoon, I don't want to put 2. I want to put 14. Because if this is 12, I got to keep counting up. 4 o'clock is really 16. This is really 18 when I put these numbers into the calculator. Okay? So again, I'm going to enter this. These are all my x values. These are all my y values. I'm going to go back to my calculator, go to Stat and Edit. Go here. We're going to clear this out. Clear. Push the down arrow. Clear. Down arrow. And I'm going to enter this data. I'm going to pause it. While I enter it, you do the same. Okay, I have entered the data right off the data table. And now I want to come up with my quadratic function. So I'll go Stat. I'll go Calc. Number 5 is quadratic regression. You guys have to push enter a bunch of times. I just need one enter there. And there's my quadratic equation. There's the a, b, and c. So negative 0.46 I'll round that to 9. And B is 14.716. And C is negative 36.121. I'm writing these down because my calculator is going to disappear. Now I want you to notice the R squared is 0.99. That's excellent. That means the graph, the equation that we have really fits perfectly to the data. Okay, so I'm going to write down my quadratic function. Negative 0.469, and I guess I should put a 0 to be really precise. Negative 0.469 x squared plus 14.716x minus 36.121. And there's my equation. My correlation coefficient, R squared, is 0.99. Very good. Okay, now again, I can use this to make some predictions, right? I'm going to use my model. I'm going to go back to my calculator, and I'll go to y squared, and I'm going to clear that out. And again, I'm going to pause this as I type in the equation, the one that I just wrote in green here. I'm going to type that in. Okay, now I have entered the equation into the calculator under y equals. And now I want to look at the graph. I don't want to go directly to the graph. I want to go zoom number 9. Oops, something's wrong, huh? Oh dear, I'm going to go find it. Let me pause. Okay, at least doing this on the calculator where you can see the date, the points, and the curve, it's easy to find your mistakes, or it's easier, at least you know you've made one. I just wrote this number wrong off of my little piece of paper. I didn't write 36. I think I wrote 16 or 14 or something. So fix this. It's negative 30. You probably already realized that because you're looking at your screen, your calculator screen. It's negative 36.121. Okay, so I've fixed that here, also in my calculator. And now when I go to zoom number 9, I should see some data points and the curve going nicely through them. Okay? Now I'm going to use my quadratic equation to predict the temperature at these two times. So this is just like last time. I want to figure out at 11 o'clock is X, what's Y? So I'll go to second calc, value, and I'll type in 11. So this says at 11 o'clock the temperature is right around 69 degrees. Because that's my output there, that's my Y. Right? These are all the X's, these are all the Y's. And then I want to do the same thing for 10 p.m. Now I got to be careful with 10 p.m. because 10 p.m. is 22. If you're thinking military time, it's 22. Right? If 6 p.m. is 18, I want to do 22 for 10 p.m. Enter. Oop. Oh, I think it won't let me do that because it's off the screen. I'm going to remove that question. I'm going to remove that question for you guys. Okay, next we're going to use the graph and the equation to predict the high temperature for the day and when it will occur. Now, we have another feature on the calculator. The high temperature is like right here, right at the top of this parabola. That's the high. So I can use my calculator to do second calc. And this time I'm going to pick maximum. This is going to help me basically find the vertex. Oh, second calc, number 4, maximum. Now, I think we've done something like this before. I need to tell the calculator where to look. So I have to move the cursor. So first I'm on the left side, and then I push enter, and now I move the cursor, and I'm going to put it on the right side, and push enter twice. And it will tell me that the maximum point is 15.688. That's a time. And the high temperature is 79.3. Now you might be thinking, but that's crazy. The actual high temperature is 81. Yes, the actual high temperature is 81, but we're using the model. We're using the equation, and you can kind of see that on this graph, the actual temperature is a little bit above the curve. According to the curve, to the equation, the high temperature is 79.3, okay? And it would happen at this time. That's like, 3:30, 3:45, something like that. Okay, So we use your graph. We're going to predict the high temperature. The high temperature will be, what did we just say? Oh, I got to go back. I don't remember. High temperature will be 79.3. Okay, degrees. So from here, what you guys are going to do is you are going to work on some more quadratic regression problems. You need your calculator to do this homework, so I am expecting that you're going to do the homework right here in class, right now. Good luck and work with each other, ask each other for help, kind of compare answers. I'll be putting an answer key up, but probably not until next week. See you then. Enjoy your 4-day weekend.